Alright, so today we are in chapter 8, and you're going to see it says pre-day 1. So we've added this one in just to kind of get you ready for this topic. So today we're working with multiplying monomials. I don't think I see that right. So, warm-up activity, pretty easy part to it. Identify the exponent and the base in the expression 13 to the 8th power. So we'll make the exponent yellow and the base blue. What is the base on 13 to the 8th power? Just make sure we understand that vocabulary. Reagan? Yeah. So the base is 13. That's your main number, which process of elimination means our exponent is 8. What does 13 to the 8th power mean? Alex? Very good. 13 multiplied by itself 8 times. 13 times 13 times 13 times 13. Do not make the mistake doing 13 times 8. That is not what that means. So, not sure why I did that. Okay. Evaluate the expression x squared when x equals 10. Pretty simple. You would just input 10 in for x, so we'd have 10 squared, which is like 10 times 10, which is 100. So take a couple seconds, go ahead, I'm going to pause this real quick, do number 3, 4, and 5, and let's see if we can come up with what the expression would equal. Alright, coming back to it, so when we look at these, on the second one, a cubed when a equals 3, notice, I know you guys have different ways, and if you're using a calculator, it makes it a lot easier. But when I wrote this out to 3 times 3 times 3, personally, so I keep things organized, that's where I do my little filter down. 3 times 3, and I get 9. And then I just drop everything down. If it would have been more, I would have just wrote out everything. So don't worry about showing, or don't be hesitant to show your work. Make sure you show it and keep everything organized so you don't make stupid little mistakes. So, speaking of mistakes, I'm going to make sure I didn't make any mistakes. I hope I did. So we get 27. When you get to 5, 6, and we get to fractions, I saw some people that went to decimals. No, leave it in fraction form. The only one I would say to go to decimal, if we ever go to decimal, would be if it was like an easy decimal, like half. So it was 0.5. Then maybe, but for the most part, go ahead and leave it in fraction form. So 5 6 times 5 6 is 25 36. You can go ahead and check, can I simplify? If you can't, you leave it there. And then z to the z cubed, when z is a half, it's a half times a half times a half, which hopefully you got 1/8. Any questions on those little warm-ups? You won't feel good with those. Awesome. All right. So today's I don't know why my board gets shut off over the weekend. All of a sudden it doesn't work right. Okay. So today's learning goal is I can simplify expressions using properties of exponents. That's what we're really going to focus on, is simplifying expressions with exponents. So when we have 2 to the 4th power, we've already identified that means 2 times 2 times 2 times 2, which, when you solve for that, equals 16. Once again, I would show my work just to make sure I don't make minimal mistakes, especially when it's kind of easy multiplication. I make sure I show how I filter. This is 4. I have these over here. I can filter those down to 4. And 4 times 4 was 16. So we're going to go ahead and do the next 2. And the next one is 5 to the 5th power, which we will write out means 5 times 5. And we will do this 5 times. So go ahead, solve for this one, whichever method you're going to use, and then we'll compare. I'm going to do my method up here. did we get 3,125?
Yes.
No? Okay, so hopefully when we did this, once again, the way I broke mine up was I did the first two fives, gave me 25. The other two fives gave me 25. And then I still had a 5 left over. And then I would have multiplied 25 times 25, got 625. And I still had that 5 left over. It's okay, you can multiply any way you want. You could have done 25 times 5 times 5 times 5. But just show your work. Even though I used the calculator, I still showed my process. Okay, last one, 10 to the 7th power. What are you going to get on that one? Is there a shortcut method when we work with tens, by the way? Katie? Good. So how many zeros are we going to put? 7. Good. So if you're ever confused and you're thinking of this, always do an easy one. Like even to make sure I was almost 99.8% sure. I was like, I don't want to look like a fool. So I did in my head real quick, 10 to the 2nd power, which is 10 times 10 is 100. Well, there was the 2, and there's 1, 2 zeros. So anytime I'm trying something, if I'm not sure, I do an easier problem. So this would just be the 1 and 1, 2, 3, 4, 5, 6, 7. So that is 10 million. If you ever have a question on it, you can still work it all the way out. All right, so those are pretty easy. Here comes the part that might be a little bit different for you. Products of powers. Okay, this is going to happen when we have like bases, but our exponents are different. And it's pretty simple. When multiplying like bases, just like they have, so like bases like here, x, which could be any number. When I'm multiplying two numbers that are the same, but their exponents are different, you will add the exponents. So if it's a variable, we're not going to be able to put them together quite yet. So that's why we got n plus n. If we knew what the exponents were, 2 and 3, we would add 2 plus 3, and that's to the 5th power. And when we do an example, it's really going to make sense. In fact, if we even look back at 2 to the 4th power, if I would have done 2 to the 2nd power times 2 to the 2nd power, really what I'm doing is 2 squared, which is 4, times 2 squared is 4, and 4 times 4 is 16. We still get our same answer. If I would have done this, my base was 2, and 2 plus 2 is 4. The reason we're adding them is it's just kind of showing how we're grouping it. That 2 squared was there. The other 2 squared was there. I'm still putting them all together.
So like on the other example, why was it 2x or 2x with the exponent?
Because your base stays the same. We don't multiply our bases if the bases are the same. So you'll see, let's do an example, and I think that'll help. That's a good question. So, simplifying the expression, write your answers using exponents. Our first thing is we want to identify our bases. So I have 10, and 10 is my base. My exponents are 6 and 5. So when our base is the same, we keep it the same in my answer. So this becomes 10, base stay the same, and now we add our exponents. 6 plus 5 is 11. And that's our answer. Yeah, that's a pretty big number. So when we try number 2, our base is 6 in both of the answers, our problems. So in my answer, my base is 6. our exponents are 8 and 5. So 8 plus 5 is going to be, which this becomes 6 to the 13th power. So real quick, go ahead and do number 3. Turn, check with your neighbor. Did you guys get the same answer? Should be pretty simple. Did you guys get the same?
I was kind of scared at first.
Alright, so we should have got k to the 13th power. Now, today's homework was only that. It would be fantastic.
Oh, come on. Wow.
Alright.
Easy.
So, now we're going to get to multiply monomials. Now, this looks kind of confusing, but really when we break it down, it's fairly simple. So, first thing is I have 3x to the 4th z to the 6th times negative 6y to the 4th. And they told me my answer is negative 18 x to the 4th, y to the 4th, z to the 6th. I always like seeing a problem and seeing the answer and then trying to figure out how did they get the answer. That's kind of how I teach it to myself a lot of times. But let's go ahead. So, if we look at how they did this, here's the 3 steps that you have to do. And we'll break them down just with color so we make sense. First thing is multiply our coefficients. Remember, coefficients are numbers that come before our variable. So that would have been our 3 and our negative 6. So we did 3 times negative 6, which is negative 18. Second, put your bases in ABC order. This is something that when people are always working in math, yeah, because the commutative property, we can mix them around, but it's best when we put them in alphabetical order because here we have X, Z, and Y, but when we get them in our answer, we want to put them in order. So X, Y, Z. So you want to put your bases, your variables, you want to have them in alphabetical order. And the last thing we did is same thing we just said. Add the exponents of like bases. So here, x to the 4th. Well, there was no x over on the negative 6y to the 4th. So my answer stays as x to the 4th. Here, the next letter was y. Well, it's to the 4th. So it stayed the 4th. And then z, and z was all alone. There was no other z. So it stayed z to the 6th. On our next example, you're going to see where we will be adding them. But you multiply coefficients, bases. So remember, the base could be our variable, or it could be a number if it has it to an exponent to it. You're going to put them in order and then add the exponents. Let's try. I think we only have, okay, we're almost done already. Yep. So, if we look at this one, we'll do number 4 together, and then I'm going to have you do the next one all by yourself. So, number 4, what am I going to do first? Katie? Good. So, we're going to do first our coefficients. 2 times negative 13. So, negative 13 times 2. And I would get negative 26. I know my answer. I'm going to negative 26. You may go back in your notes if you need to look. What will come next? Yeah, so I'm going to put my bases in alphabetical order. There's a B, there's an F. So I'm going to go ahead and put it as B, F. Okay. And for me, what I do when I solve these, I'm going to say, okay, it was b to the 7th times b. Good. If it's just b, that's like b to the 1. So that would be b to the 8th. I don't have any f, and I just have one f, 4. So f to the 4th power. That is our answer, simplified. Okay. Here's what I'm going to do. I'm going to pause our recording. Then I'm going to do the work up here. But while I'm doing the work, go ahead. You can work with your neighbor. I want you to try and solve 3x to the a power, y to the b power, z to the c power, times negative y f to the power, or, oh my gosh, negative y to the f power, z to the g power. Alright, go ahead and work on this. Check with the neighbor if you need some help. Okay, so our answer should have, I try to color code mine just to help you guys see my answer, break it up, but our answer was 3x to the a power minus yb plus f power zc plus g power. Now, why do you think that they gave us a question with all these variables? To kind of confuse you. But what else do you think they're really trying to show us, Maddie?
To like help us like understand like no matter what you can always like put it together.
Yeah. So really it's just showing you the process. We really shouldn't come up with ones that we have to do all this, that we should have numbers that go into it. But it's only focusing on the process and the steps. Recognizing that, hey, I have to look at my y's and the variables, I would add those. So instead of getting a number, it's just b plus f. Recognizing that whatever that power is, I add that power. So they're just trying to show us how we add the powers. Not really worrying about what the final answer is. All right. Last problem, I think. Oh, there's two. Then there's another thing. Sorry. Okay, this one. This one, we had something similar to this on the test, and you guys got tripped up on it. They made it a little easier. They pretty much give you everything. They're just asking you to do the problem. The volume to a pyramid is V equals, so volume equals a third times length times width times height. Find the volume given values of length, width, and height. So volume equals. So I'm going to go ahead and say V equals 1/3 times 6x to the third times 2x squared times 3x. Okay, so there's my equation. Nothing has changed. We're still going to do our 3 steps. Katie told me last time, what is step 1? What's the first thing we want to do, Rahab? Coefficients, good. So I'm going to look for my coefficients. I have a third, 6, 2, and 3. So I'm going to go ahead and get rid of a third times a 6. A third times a 6 is 2. And if I want to be showing my work, I could say, okay, so then I have, this is 2 times 3. So that's like 4 times 3. So I'm going to have 12. So in my answer, V equals 12. Now, what am I going to do about my bases and my exponents?
You add your exponent.
Okay, because all my bases are the same, right? That's an important step to recognize that. I don't have to put these in alphabetical order because there's only one base, x. So in my answer, it's going to be x. And then we have 3, 2, and that'd be like a 1, which it would be what, Daddy? X to the 6th. Oh, that was a bad 6. X to the 6th power. And that would be your answer. The volume equals 12x to the 6th power. The only way we could solve this any farther is if they tell us what x equals. Then we find the exact volume. All right. Checking for understanding. To be honest, we have 6 minutes. You guys have been doing pretty good. I want you to start on your homework. Unless anyone wants to work. If you solve this one, I'll come around and look at it with you. So we don't have to do it now in class. But if you do it and you want me to look at it, fine.
That would be the best Christmas song ever because you're all not organized.
Alright, let's change your homework just a touch for you. Oh, I'm going to pause this.